So we sort of have a natural experiment for what happens when you put aerosols in the stratosphere, which means they cool the planet. They eventually go away in a couple of years, so you can't rely on just doing it once, but they work. They cool the planet because they affect the energy balance just like CO2 does, just the other way around.
Today's guest is Dr. Daniele Visioni, a climate physicist, assistant professor at Cornell University's Department of Earth and Atmospheric Science, and a Cornell Atkinson Faculty Fellow, whose research looks at how tiny particles in the atmosphere shape the planet's temperature. Among his more pronounced skills is in the clear explanations of climate change through everyday language, including his analogy of carbon emissions as planetary debt. We talk about the fear of acting under uncertainty, why innovation needs guardrails, and how local projects like the Great Barrier Reef restoration can guide global solutions. His perspective goes beyond models and data. It's about ethics, shared responsibility, and what cooperation on a global scale look like when risks are felt unevenly across the world. Let's start the show. Professor Daniele, very nice to have you on. Thank you for coming.
Thank you, Marcus. Pleasure to be here.
So there's a lot of areas that I want to talk about: stratospheric aerosol injection, volcanic forcing. I want to talk about your Great Barrier Reef rescue or restoration involvement. I want to talk about all of that. But maybe I sort of wanted to understand a little bit more about carbon dioxide removal and solar radiation modification.
Mm-hmm.
So I'm hoping that you maybe can give us that as a backdrop for starting to investigate and better understand the more niche specific area of your climate research.
Yeah, sure. Okay. So I would start, observation number one, I would say we can all see temperatures are going up. That is one thing we can observe. We expected that to happen due to increasing CO2 concentration. From a physical point of view, the reason why temperatures are going up is because the Earth is what we call is in a energy imbalance, as in there's more energy going in than energy going out, and that is also something we can measure. We have satellites that can measure how many photons are coming out of the planet, how many photons are going in, so we can see these energy imbalance, and that's what leads to a temperature imbalance. The moment we stop putting more CO2, the moment CO2 concentrations stop growing, it's the moment in which the temperature imbalance will slowly catch up and the planet will re-equilibrate itself due to these increasing temperatures. So over long time scale, the only thing that we can do is to stop increasing CO2 concentrations to make sure we also eventually stop warming the planet. But that's going to take time. It's taking time. It's not going anywhere, actually, I would say, in the sense that emissions are going up year by year. So at that point, one can say, what can you do? Well, one thing you can do is adapt to that one way or another as much as you can, but how much we can adapt to this new world, that's a big question. So the second thing you can do, of course, second thing you can do is reduce concentrations through emissions. But then what you can do is try to capture some of that excess CO2 out of the air. So the sooner, the faster, the more you do that, the easier it's going to be for the planet to catch up and the easier it's going to be for the planet to equilibrate. So if we had ways to capture the CO2 or other greenhouse gases right out of the air, that would help us restore the planetary balance. Problem is that we don't have any ways to do that at scale right now. Whether we're assuming really technological ways like direct air capture, so really capturing air and removing CO2, that takes a lot of energy. Right now, energy is expensive and we need energy for other stuff. So they're really unclear where that could work, except few places where geothermal energy is very abundant, like Iceland. You could think about enhancing the land carbon sink. So for instance, in layman terms, growing more trees, but trees take time and trees also burn down when there's a fire. So that kind of carbon storage is not really that permanent. And the other thing you could do is do something like increase the ocean capacity to capture carbon, and that that is something that people are looking into. But whether how much that is feasible to do, how much you can sort of reduce the ocean acidity to make sure that it can capture more carbon from the air, that is also one big question. How feasible is that? And at that point, if emissions are going up, temperatures are going up, and you don't have a way to remove CO2 from the atmosphere, you can ask yourself, okay, what do we do in the meantime? Especially if, as temperatures go up, risks go up, right? And extreme weather goes up, but in general, all kind of exposures go up. Well, at that point, you can say, can we intervene somewhere else in this energy balance? And that's where SRM, solar radiation modification, sunlight reflection methods come in. The idea that the other part of the energy balance that we can affect is the amount of incoming energy, so the energy that we get from the sun. And if we were able to reflect a tiny fraction more of this incoming solar radiation, we could restore the planetary balance some other way. Now, that is not a solution. That is not a solution for the long run, because you're still, if you, the more CO2 you have, the more you're going to need to reflect, the more you're going to need to cool. So the better thing is still to reduce CO2. But in the meantime, this could be a way to avoid some of the major risks from climate change.
So there's two things that I'm sort of going back to. One is a comparison to the body, which is, if you're getting overweight, there's two things you can do: either eat less or work out more, and they tend to go hand in hand. And I'm looking at the Earth the way you're describing it in terms of CO2 production. It's either we find a way for CO2 to get removed, or we reduce the CO2 we're actually consuming.
Mm-hmm.
I'm going to table that for 1 second. I'm also going to talk about or reference something that you had in some of the research that I was doing. You referenced the scheduling, how long we have to figure this out, and the idea that we can solve it more sustainably is different than solving it immediately. And within the world of real estate, I always go back to, there's this project management triangle. There's three things: it's schedule, budget, and quality, that tend to work hand in hand. But you can tend to have two, not all three together, meaning in this case, you can have high quality CO2 reduction, but it might come at a high cost and a long time frame. I'm using this as a hypothetical, something that you can critique. And so between those two things, there's the micro, then the semi-micro, then sort of the semi-macro, and then the full macro, being what's happening in your village, what's happening in your region, what's happening in your state, what's happening in your country, now what's happening in the world. So I'm sort of going in a few different directions, but I wanted to get your take on, I don't think that this is something that should be political. There's a number of other issues talking about, you're in the US now. Our healthcare system should not be a political conversation. I'm not opposed to getting political as it relates to this, but let's, for the time being, just assume that most listeners, most audience members are taking for granted that climate change is here. It is dissimilar to prior climate changes in historic contexts, that it is a more severe imposition on our future well-being and our likelihood of survival. So let's just take that off the table. How do we start to navigate solutions more sustainably between countries and regions? And I'm sort of thinking, like, if I'm not mistaken, the largest producers of CO2 would be the biggest population countries, right? I mean, China and India are the ones that sort of surface to mind, but they're by no means the only perpetrators of this, mm-hmm. right? So where do you help us understand bridging the gap between the academia and what we can do within the political system, but as a plebeian, as a layman, supporting our local infrastructure to start implementing this? Mm-hmm. Sure, we can start to drive electric vehicles, but how much is that going to really do? We can eat less meat. How much is that going to really do? Is it recycling more? I'm throwing a lot at you, but I just wanted to give you a little tapestry that you might be able to pick from, and we can start to dive in more idiosyncratically as it relates to the work that you've done.
Yeah, okay. Yeah, that's a lot, but let's see where I could start. So I would say, starting from one of the few last things you said, right? I would say, in a way, climate change is a bit like debt. We've incurred a debt with the planet. Understanding who incurred that debt is important. It doesn't solve anything, but it is important, right? And you can say, well, who did that? And the fact is that once we put the CO2 up in the atmosphere, it stays there fundamentally, most of it forever. So it doesn't matter only who spent more today, it also matters who incurred in that debt 100 or 50 years ago. So what matters is to look at cumulative emissions. So how much not countries are emitting today, but how much they emitted in the past too. And so if we do that, the main, in a way, groups that incur the debt are Western countries, the US first, and then Europe. Right now, per capita, and in many cases per country, the emissions of the US and Europe are lower than the ones of countries that sorry, not per capita, but in general, the emissions of most of Europe are lower than China, Russia, or India. Sorry, not Russia, but China or India. But per capita, so for how much each single person is emitting, the values for Canada, the US, Europe are still higher than everything else. The fact, though, is that, and the point of most climate policy, or most in general international policy, has been also acknowledging the fact that, well, the reason why we've emitted more and the reason why we are where we are is partly because of we've grown as a society and as a civilization, and we emit more because we also have more well-being, and we definitely have more well-being in Europe or in the US than people on average do in China or India, and so, or in Africa for that matter, or anybody else or any other developing country. And so those countries want to get to the same level of well-being that people have in the Western world, and that's going to lead to more emissions unless we break the loop between emissions and well-being. How do you do that? Well, you use energy that doesn't come from fossil fuels, that is also that is also cheap at that. That was always the point of renewable energy, not just a way to reduce CO2 emissions, but also as a way to have energy that is cheap and available as much of the time as possible, right? So on sort of the first part of identifying the problem, in a way, is also, yes, finding out that kind of solution, right? The fact that we can build a society in which everybody has more, but also one that doesn't keep incurring debt with respect to the planet. And then, but it's still important to also know, well, if you are in a country that has never emitted that much, so you're not part of the problem, you're not the person or the group who caused the debt, but still you are one of the countries getting hurt more by climate change, right? You're a country that's seeing more hurricanes like the one that is happening right now, or a country that is seeing more droughts. What do you do, right? Somebody still, in a way, has quote unquote to pay for this debt. And so acknowledging who was the main culprit is also useful for that, to understanding, okay, but if I am a country that is poor and is getting whacked by climate change, and I also don't have the capacity to adapt, why should it fall only to me to develop and do it in a sustainable way? Maybe other countries that have developed before me and have incurred most of this debt, they have to be the ones helping me out. Okay, so this is sort of on the last part that you mentioned, but but ultimately we all live in the same planet, so whoever emits CO2, the planet doesn't care. What matters is
Well,
only the amount at the end.
that's sort of where I was going with
Mm-hmm.
this, because even if, say, India turns around and reverses course and somehow manages to halt their CO2 production by 80%, something unfathomable, that is going to do a lot, but not enough, right? I mean, as it relates to the entire global community. And so I'm sort of, maybe this is a good time to talk about stratospheric
Mm-hmm.
aerosol injection, because volcanic forcing. So in the research I was looking at, you alluded to this in one of your TED Talks, but Mount Pinatubo
Mm-hmm.
in 1991, is that the correct pronunciation? I
Yeah,
think it was in yeah.
yeah.
There was four that were sort of noted that in my research: El Chichon, Tambora, and Krakatoa. That goes back to 1883, 1815, 1982, 1991, where there were measurable differences in that region for, let's just use Mount Pinatubo, and I could be incorrect, but for half a degree Celsius for 1 to 2 years, which is about a degree Fahrenheit, give or
Mm-hmm. Mm-hmm.
take. And that's pretty staggering to think of for that region. But how does that apply on the global scale? What is that really? Is that a drop in the bucket, or is that meaningful overall?
You mean in terms of the cooling? So
Yes.
that cool. So roughly the planet after Mount Pinatubo erupted, the planet cooled around zero point 0.3 to zero point 0.4 Celsius globally.
Oh, okay. So that was
Yes,
global.
it was
So it was
global.
a
It
more
was global.
universal.
It was
Okay.
global. Yes, over the next 2 years of the eruption. Yes, that's how long the cloud stayed. So it's it's actually a third of all the climate change that we experienced in the last 100 years. Roughly now we're at 1.2, 1.3 Celsius of warming. So that would be a third to a fourth of all of the warming that we experienced happening because of a volcanic eruption, which are just very sporadical. So we can't rely on
So
them.
how are you using that? I mean, because that's really the volcanic eruptions are what started the stratospheric aerosol injection idea, that concept, right?
Yeah, it was the concept is so right after Pinatubo happened, there was actually a very famous paper from, well, somebody who's now pretty famous himself, Jim Hansen from NASA, who at the point in 1993 wrote a paper and said, we our climate models, we didn't build them to assume the existence of volcanic eruptions, and yet if we are able to predict how much cooling there will be after Pinatubo, that means that that's sort of an acid test. It means that our models, work pretty well, that the physics underlying these climate models work. And indeed, those were the first climate model simulations of volcanic eruptions, and they said that the planet was going to cool by a specific amount, and that's the amount that indeed we observed in the real world. So we sort of have a natural experiment for what happens when you put aerosols in the stratosphere, which means they cool the planet, they eventually go away in a couple of years, so you can't rely on just doing it once. Uh, but they work. They cool the planet because they affect the energy balance, just like CO2 does, just the other way around. And so there were multiple people that started discussing whether this was something that could be replicated by humans to reduce temperatures in a more stable way. Of course, it would mean having to do it not just once, but continuously. But the point that many people made over the years, all the way then to a famous paper from Paul Crutzen, who was the Nobel Prize in chemistry for his discovery of the ozone hole. And he said, maybe this is considering how slow we're going towards mitigation, maybe this is worth looking into as a way to bridge the gap.
So how does tell us how that works?
How it would work fundamentally. So here's volcanic eruptions. They throw a lot of stuff in the atmosphere all the time, but only a few of them are what we call explosive volcanic eruption. And so they release a lot of material not in the troposphere. The troposphere is a relief, and that's where there's clouds. And so if you throw aerosols in the troposphere, they come down with the rain pretty fast. That's fundamentally the problem with pollution and with acid rain, right? That we put aerosols all the time in the atmosphere, but they don't have enough time to cool the planet because they are washed out by rain and by clouds. Once these volcanic eruptions explode and they throw stuff all the way up to the stratosphere is 15 to 20 kilometers above our head. There are no clouds. There's almost nothing there. There's no turbulence. And so if you put stuff up there, it stays there and only very slowly moves poleward due to the circulation and then falls down. So in an explosive volcanic eruption, you get the same material that you would get normally from an eruption, but it doesn't affect the climate as much. But in this case, these aerosols, these particles that are released by the eruption, they stay in the air for a year or two. And as they stay in the air, they are exactly of the size, the perfect size to reflect incoming solar radiation because they're the same size of a wavelength of visible light, so around alpha micron in size. And they're perfectly well suited to reflect solar radiation, and they affect the energy balance. They cool the planet. And the idea behind stratospheric aerosol injection would be, okay, could we replicate what volcanoes do and just do it artificially to make sure that we counterbalance the increased absorption from the CO2?
So that's like if there's two processes, one is applying the brakes, the other is going in reverse. That's sort of applying the brakes.
Yep. Yes.
Going in
Yes.
reverse would be the removal of the
Yes.
CO2.
Indeed. Yes. Yes.
So I guess so. What have you encountered in terms of experimenting with this? And I would imagine that there's some fear about what this does to our atmosphere in general. Like, is it a sustainable thing? Are there consequential damages down the line? Um, I don't know. I mean,
Mhm.
I don't know what I don't know here, but what have you experienced in putting this out there and stress testing this and from the public?
So yeah, the point itself of researching in this space is not to try to sell this or to try to claim that it works, but actually to figuring out would it actually work, right? There's of course there's this big test that happens once every 30 years of a volcanic eruption, but would this actually work in practice? Which means understanding everything, all of the potential implications, the risks, and maybe even the potential benefits. And of course, just like you said, well, once you set out to research something, you don't know what you don't know, right? And so the point is also to making sure that you don't do this kind of research siloed in just a couple of people, but that you expand the disciplines that are looking at these, the amount of people that are looking at these, to try to understand all of the things we might be missing out on, right? And yes, for something like this, and this also connects with the public, right? Because of course, a normal person will not have the understanding or expertise to understand this, but he might also not believe one single person or one single scientist. But if you get many, many people looking at this and trying to understand based on their expertise, what impact would this have, then you start building sort of a trusted source of understanding that can help you eventually decide, is this something worth thinking about, right? Oh, eventually, even for governments or governmental official policymakers, they don't have the capacity to understand deeply every single solution or thing that is proposed to them, right? Eventually, they would be like, okay, is this something that is worth thinking about or investing some time or maybe even arguing with some other countries over? And the only way you can do that is saying, yes, look, this is the amount of research that we've done, this is how we've stress tested it, this is what we understand. And then it's pretty clear, and it has to be always clear, that it's not the scientists making the decision about whether something like this would ever actually happen in real life or not.
Are you seeing any benefits to the use of, I guess, the greater powered AI components in doing any data modeling here?
We're definitely starting to explore that. A couple of projects trying to understand how you could use machine learning based model surrogates that are much faster than the climate models that we use right now to speed up or accelerate any of this research, for sure. We still sort of research in this field is still emerging, so pivoting to a new thing, it's pretty hard, but I've had multiple discussions. I have a few research plans exactly on this. Yes.
So, can we transition to the Great Barrier Reef Restoration Project?
Sure.
What are you? So, can you just tell us a little bit about what that project is, how you got involved, and then I have questions about
Yeah, sure. So
where we're at.
so I mean, it's so the entire project is fundamentally one of the things we are observing as a word when it comes to climate change is the fact that if you have warmer air, you also have warmer oceans, especially at the surface, and essentially corals and coral reefs are kind of boiling alive and dying, especially when you get massive heat waves that are much warmer than before. And coral reefs they're a boon for many ecosystems, especially the Great Barrier Reef in Australia, but also in Florida. There are plenty of places that benefit a lot from the Barrier Reef. They are a great way for sort of, they're the equivalent of forests in a way on land. So they let a lot of animals be in there, they capture carbon, they regulate the ocean in many different ways. So they're important. Plus, they're beautiful and they're useful. So when Australia started seeing what was happening to their Great Barrier Reef, they started asking more directly the question, okay, what do we do about this? And again, this is not something you can say, well, we'll reduce emissions, because reducing emissions doesn't stop the problem right now. And so, well, there have been multiple proposals of things that could be done to try to help out these corals. Amongst them, one of them was also the idea of spraying clouds over the Great Barrier Reef to make them brighter. This is another method of solar radiation modification called marine cloud brightening, where we know that if you add sea salt to clouds, they nucleate more. So there are more particles, there are more cloud nuclei, and these clouds become more reflective. So the idea is, could you do that and sort of produce a small scale, right, a very regional shading pattern that could avoid the corals from boiling alive by reducing the amount of sunlight that you get? Um, there are also other proposals. It's not like I have a big role in all of these, but the only thing is that the Australian government has this risk review board for a lot of these proposals that have been done to try to um, protect or restore the Great Barrier Reef. And I'm one of the experts that is sort of sits in this board and evaluates the risk, the trade-off, and the risk that might come with many of these proposals. Right. So at this point, um, none of these proposals are being tested at large scale. They're all in the phase of trying to understand whether they would work or what would be the risk if they were to be applied. And the point of having a risk review board, risk review assessment panel, is to have expert and say, okay, but have you thought about these? Have you thought about this other thing? And sort of trying to assess the risk that would come with these proposals.
So you got your PhD and your master's in
Mhm.
Italy, and I have to give you a lot of credit. I've watched several of your speeches, and you speak English terrific. But to think that you're now conversing in this very unique language within English, that being physics and climate study. What I'm just curious, have you encountered, and I'll backtrack for a second because this is sort of how I'm looking at it, but I'm not fluent in any other language, but I have studied other languages. And by virtue of having studied other languages, I think two things. One, I learned how to speak English better because I just understood how the words functioned with each other from a better perspective because they function differently in Italian or in Spanish or in French. But also, I think more importantly, by way of learning at least parts of other languages, you start to understand the way that community thinks
Mhm.
or views the world in some way. And having, I mean, I know you've worked with over 300 scientists on a number of peer reviewed papers. I have some questions about how you do that type of research and reporting with that many people. But before we get to that, I am curious, do you see any regional lines of thinking that you seem to have transcended just by virtue of traveling and doing research from more than one continent, but in working with other scientists, like on the Great Barrier Reef Restoration Project, are you seeing commonalities or methodologies that are unique to these different regions?
Yeah, I feel like so. Well, starting from the Great Barrier Reef, I think the main thing is the huge emotional attachment than people there have towards it. And so when you're trying to think about something that is, again, so local, like the risk danger is global, right? Again, there's nothing that an Australian can do against a marine heat wave. And so this concept of something that local you can do at least to save something, or at least to save some of that, I think it's a really interesting. One of the main reasons why I joined this board is because I was really intellectually curious to understand how this project and the way in which the Australian government is very carefully doing engagement also with the local public, as in also with indigenous communities that have lived around the Great Barrier Reef for hundreds of years, how everybody understands this. And I think I already had, well, I haven't been in that board for a while, but I already had a couple of very interesting insights in somebody sharing that their perspective was, well, almost we were discussing risks and benefits, and this person shared something like, normally in my experience, it's always about the risks, never about the benefits. Like ultimately, the benefits are secondary, but what people care about is the risks. But also on the other hand, sort of thinking, okay, but are we letting all of these worries about risks bogging us down and slowing us down when what we should be finding it is solution? So there's this tension between moving fast or moving too slow, right? And being careful. And I find that that is one of the things that it's really different regionally. And I would say, again, as a European that now has been in the US for a while, there's really a huge difference in the way this is perceived, right? The move fast and break things of the West Coast versus the more cautionary approach of European countries and Europeans in general. And I think really this is the so and I think that this idea of SRM is really the one in which this tension becomes the strongest possible, because you have this concept of we could be doing something, not just preventing something from happening, but like maybe doing something. And it does come with its own risks. Nothing is risk free, that's true. But at one point, you have to decide whether some risks or trade-offs are acceptable to you, understanding that if you decide to do nothing, that is also going to have its own impacts. And maybe they're going to be larger. But so, how do you decide whether something is acceptable or not? I think it's really hard. And this is the one that I'm finding that different communities have really different perception. For instance, there's also been, I also work with a lot of colleagues and scientists from the global south, from Africa and from Southeast Asia. And there's also been a lot of research being done with the perception that people, for instance, in Africa have about these kind of technologies, this kind of SRM. And a lot of times the way they respond is like, well, we didn't cause this problem. So why are you asking us this is whether we should be fixing it or not? Like, you created this problem, you should be the one to fix it. But in these, I would say that definitely also in between the US and Europe, there are some different perspective of what it means to fix the problem. And sort of to go back to the first example that you had, right? You can say, well, we could be building, if you build a house too fast without caring about quality, the house is just going to crumble on your head. But if you take 30 years and you have nowhere to go in the meantime, you're going to live 30 years, under the weather, which is not great. So balancing out these things and what's your acceptable level of risk, it's really hard. And really, I'm finding that, yes, the Germans will have a different perception of that compared to the Americans, compared to the British, compared to the French. And I think it's really interesting to see and observe.
Can you give me an example of what you said about the West, which is, I think you said, do things fast and break
Hmm.
them?
Yeah, no, move fast, break things. The Silicon Valley,
Yeah.
yeah,
Yeah.
right. And I think this is exact right. So for when it comes to SRM, again, there has been a small company called Make Sunset who from the Bay Area that essentially said, okay, so you're saying that these things work? Cool. Then we're just gonna sell cooling credits where people will pay us to launch balloons from San Francisco, and they will pay us to launch these balloons, and we assured them that there will be some cooling. And they just thought, well, who cares about side effects? Who cares about legitimacy or any of that? Let's just do it. And that's, I think, the quintessential West Coast Silicon Valley way to proceed in many ways, right? You do something and then you think about the risks or the problems after. But on the other hand, there's also a lot of danger in the opposite, which is, well, nothing in this world is 100% certain. Nothing we do. Every kind of decision we make, both at the small scale and at the large scale, at the government scale, will always come with some form of uncertainty. But there is a point in which you can get uncertainty paralysis. Like you say, oh, I'm never going to be able to perfectly predict whether this action will have the consequences I intend or whether there are unintended consequences. Therefore, I will not take this action. And in a way, that has been partly the European approach in many different realms, right? But these comes with its own problems. Just as an example, when during COVID, during the first waves of COVID, I was already in the US and I got vaccinated all 3 doses before my parents in Italy, they were in their 60s, could get their first dose. And that was because the European approach to the risk assessment of vaccine took a lot more time. And ultimately, it's a trade-off, right? Because if it is a trade-off in that case, as it is in every other case.
What do you think? Like, I think of, I'm not sure if you're familiar in California, Title 24, which was passed, I don't know, it had to have been probably 15 years ago, maybe a little bit more, but it was basically a standard under which new construction needed to meet. That was some form of LEED certification, basically to reduce energy consumption by way of lights turning off automatically when you leave or enter the room, having more circulation within the building so that there's a better cooling effect. That became a little bit of a standard that other states started to replicate in some format. I use that as a little bit of an example because there's a common theme in two things that I'm going to bring up, but it's about bringing it back to something local and then extrapolating that into something more macro. And I think of these sort of markers of goals, and I can't help but think of the Paris Climate
Mm-hmm.
Accord and withdrawing for, like, whether whether it was right or wrong, that's not even what I'm sort of asking about. But my point in what I'm interested in is that 20-year, 30-year sort of horizon where there's a percentage reduction. There are some goals that are set that I think actually, when implemented into more regional areas, allows for appropriate lab modeling, so to speak, right? Where you have a bunch of different regions all experimenting, providing different levels of incentives to hopefully stimulate GDP at the same time of reducing these types of um, greenhouse gas effects, allows sort of thousands of different case studies that sort of can showcase what's working and what's not working as effectively, that then get sort of trickled back up into a more cross-pollinizing type of user. Where do you think we go? I mean, that's sort of like what seems to make the most sense among international diplomacy relative to finding some alignment, right? You can't say, your distinction at the very beginning of our conversation about our cumulative CO2 emissions versus our per capita, I think is a meaningful discussion point, right?
Mm-hmm, mm-hmm.
It's very easy for Americans to say that China and India have so much more going on, but when you compare it per individual, you start to realize, well, personally, I am contributing more on an individualized basis, and so the second thing I'm sort of thinking about is that it seems like a branding problem in a lot of ways, because I'll say I'm a lot more in tune with this because I see plastic bags, cigarette butts when I'm surfing, and it's disgusting. And it's something that I have a tactile, immediate relationship to seeing just litter, right, coming into something I use every
Mm-hmm.
day. And so there's a little bit more of a bond I have with our natural environment just by virtue of doing that. But if I were living in Tulsa, Oklahoma, I might not have that same experience. And so, the hurricane-ridden Florida regions are having a very different dialogue than somebody in Omaha, Nebraska. How do we? So there's two separate
Mm-hmm.
ideas here that I'm sort of combining, but one is branding, and one is sort of how to integrate this in a broader sense. These two are connected because how do you take something so global and make it unique and local, where there's a better alignment of what we want on the ground and how that connects to the global cosmos, the global heartbeat. You see where I'm going with
Yeah, I
this?
think. Yeah, I think I do. I think, as you said, the I would reframe this all to say one thing that definitely humans are bad at is global thinking, right? Or both in time, both in space and in
Certainly
time,
Americans.
right? But I think that that applies to everybody, and also like long-term thinking, as in you can understand and perceive the consequences of your own action at this point. So if you were to throw trash and the trash would not go anywhere but stay close to your house, then you would suddenly notice pretty soon, right, how much trash is accumulating. But the fact that there's the wind and things move means that maybe you can forget about the consequences of your own action. And in part, the the US has been isolated from some of the consequences of climate change just because, for instance, always use air conditioning, or in general is a pretty rich country that can adapt. But already, I think if you go, I don't know, in Europe where air conditioning was never a big thing and there was always a bit of a conception of, oh, you have to suffer through the summer. And now more people are realizing, wow, some of the suburbs are getting really unbearable. So there is a point in which, yes, nobody can perceive climate change through global mean temperatures. And that was probably one of the main problems with the Paris Agreement, right? That these 1.5 degrees above pre-industrial, it doesn't mean anything to most people. People can mainly understand the things they can perceive, right? And the things they care about, and how does this impact these things that I care about, whether it's, the forest that I walk around, or the Great Barrier Reef, or how will this affect anything else, right? And trying to connect it, and for trash in a way, and for pollution, this is a bit easier because it's more easier to perceive also visually, but it isn't for climate change. So there's always been the problem with climate change, which is the CO2 I put now, it's only marginally going to affect me, because I have all of the one before me. But the 3 generations from now, that CO2 is going to be so important. But I can't be asked to make decisions. I mean, generally, people find it hard to be asked to make economic decisions based on the merit of something 50 years down the line. So there's always been the struggle, and in a way, people, one of the main worry that people have about something like SRM was the fact that, well, if you also hide this warming behind these reflection, these increased reflection, people are really going to have no incentive to mitigate whatsoever. Except people haven't had this incentive based on their perception for most of the times, because again, most people don't really perceive these risks yet. And so I think that is not a worry I really buy in that sense, but really something where we can start thinking about, okay, but how do we explain to people why this matters? And now I think we're seeing pretty much a lot of realms under which, and even in the US, again, you can see cost of insurance going up, sea level rise threatening many states, hurricanes getting stronger. There's a lot of things that right now we are starting in the US are starting to perceive more, and where the question isn't the perspective would just be, well, whatever, we're just going to adapt, right? We're just going to spend more money and we're going to make do. But can we do that really and forever? Can we just spend our entire time catching up? If you build, as you said, like you build your house and you have to worry, okay, I want my house to have enough air conditioning to make sure that if the temperature goes on average 102 Fahrenheit, then I'm still comfortable the whole summer. But what if the temperature in the summer in 15 years is 104 Fahrenheit on average? Then I'm going to need way more energy. And will my energy system be able to catch up? Will my infrastructure be able to catch up? And what if this temperature goes to 110? What if there's a heat wave and it's 110 and you're 70 and you need to have your body can't cool down that much? And a lot of mortalities in that age is led by things like heat waves. How do I plan for that in advance? And partly is you can't, but you can make sure that the damage is as small as possible to begin with, maybe.
So I want to get back to your writing and your
Hmm.
research papers. So how are you working with this many different researchers and scientists collaborating and coming to any consensus on what you actually publish?
I think it's not as hard as it sounds, as in you just let the science speak for itself. I mean, for most of the things, a lot of what I've done in my research is really like, okay, we have these results from our climate models. These are the outcomes, but what do you care about, and how would you go about finding out, right? So I've collaborated with a lot of ecologists over the years, sort of saying, oh, I would be concerned to understand how changes in diffuse radiation that heat the canopy would affect plants. Cool, let's go look at that. Or, how would this affect marine heat waves and fishes? All of these things, you most of the time just let the science speak for itself. You also have to get to a point where you're like, well, is my voice more important than what the science is saying, right? So you sometimes have to take the loss and say, oh, I would say this differently, but I'm more interested with hearing your opinion than my own. So I'm fine with having these. This is easier when there's science involved, but I've also collaborated with social scientists and trying to think through things that you can't necessarily quantify. And in that case, it's really like, I think that it helps to acknowledge the fact that there's a common concern, and then that you might get towards a resolution to that concern in different ways, but to say, I am concerned about climate change just like you are. What's the common ground that we can find, and how can we push this forward?
Do you find though that by virtue of being arguably the preeminent geoengineering scientist that you get less pushback than you might otherwise?
I well, from within maybe our own kind of small community, because again, the community of people that are looking at this is pretty small compared to the climate community. But I can tell you that most of the climate scientists, they have no problem letting me know what an awful person I am because I'm looking at these issues. So I mean, and this just honestly happened like on Saturday. I posted something on Blue Sky about the research that I do, and one of the most preeminent climate scientists in the world, I guess, he wrote a lot of books. he replied back, say, you should be ashamed you're doing this research. My answer was fuck off. But aside from that, the fact is that aside from the personal, the fact that this field, that this topic of research makes people so mad means also that it's a good thing, as in, if these people, the most they can, if the people that are opposed to this research, the most they can say is, um, you should be ashamed, but they cannot find any physical pushbacks. It means that, it's good, but I want them to look at it. I don't care if they hate me or if they hate the topic of SRM. I would love for them to get in and do the research as well and show me where I'm wrong. When I say, if I say we've looked at this for a while now, and it is the thing that could, in the quickest way possible, cool down temperatures and prevent many risks. If I'm wrong, show me. I would be happy to be shown I'm wrong, in the sense that, wouldn't be on me anymore. Like, go ahead and show me. But in general, people haven't really managed to do that. Let's put it that way.
Well, you're actually bringing up something that I wanted to bring up. I want to talk about running, because I read that that's a nice place where you get your research
Yeah.
ideas and your most snarky comebacks. But before I talk about it, I want to talk about historical fencing and why that might be historical to you.
Okay. As in, okay. So what is it in general, or?
Yeah, what is it, and why is it significant to you?
Oh, yeah. So I've been fencing for, I don't know, now probably 15 years. I don't know. I've lost count. But the kind of fencing I like doing is what we call historical European martial arts, or historical fencing, which is essentially fencing going back to the source. So people have been writing manuals about how to fence since the 13th century, and it was a life and death matter. So they were pretty detailed in describing how to fence. And fencing has evolved over the centuries due to technological advances. And the fencing that we see now at the Olympics, it's what we call modern fencing, as in, it's essentially fencing that has been stripped from the original idea of, well, you're trying to survive on the battlefield, or on the field in general. But now there is these, and it has also evolved because swords got longer and thinner, and so it was harder to cut. And there are many different things. And so historical fencing is this idea of trying to go back to the sources. Many of them are Italian, so that's easy for me, but some of them are German, so there are translations, and try to understand um, how how was fencing in the past. And I find it very funny, and also I find fencing to be kind of, well, aside from the fact that it's great as a stress release, um, but also, for me, one of the things is, you learn pretty soon, especially with current swords. It's not like you can parry a blow and then just stay. You can't apply too much force because the swords bend a lot. But swords didn't used to be that way. So there was a lot of what we call sort of getting close to the opponent and binding, as in, you're trying to figure out, your sword is on the opponent's sword. And what do you do? Do you push against your opponent's sword to try to win? But your opponent, what they could do was just to, let you push and essentially use your own strength against you, right? And just let the blow pass and then attack you back. So I think that there's a lot in there in terms of, sometimes you have to parry the blow, and sometimes you have to just let the blow go and then bide your time. So yeah, it's a bit like
So,
I like it. Yeah.
what's different about historical fencing as compared to modern fencing?
So the main difference, and we have a
For
historic.
visual
Yeah, yeah, yeah.
purposes, right? For the
Yeah, yeah, yeah.
audience to think about
Okay.
what is different
So
about
so
this.
first of all, we have a historical fencing club here at Cornell. So we do that too here at Cornell too. I think the main difference is the fact that right now in modern fencing, the person who hits even a fraction of a second before gets the point. But in the real world, if I stab you and your blow is charged, your blow still has enough time to fall on me. So the main difference in a way is sort of on being more defensive than offensive, because when you're attacking, you have to not just think, will I get there a fraction of a second before, but is my opponent also going to reach me, right? And I want to stay alive. So that's one difference. In a way, this leads to, I guess, so the biggest difference is that normally you will also have a defensive weapon in your offhand, Either you have a larger sword, like a two-handed long sword, or you have a defensive weapon in your offhand. So like a buckler, a parrying dagger, a cape, something. Um, so I would say that that's, and then of course the main difference is that the swords that we use are sort of the right weight and shape as the historical counterparts, except they're not sharp, of course, but still, so our protections are a bit more padded than the ones for
I
modern
was going to
fencing.
say, and but
Yes,
you got a
we
mask.
have the mask. We have the 1700 Newton mask that it's a bit stronger than the normal fencing mask, but it's pretty safe. And then we have just padded jackets and padded pants. Also because you can eat
But
below the belt. That's fun.
oh
Yeah.
boy, but they're not epis that bend.
You can essentially the épée are kind of the sides, the sort of late Renaissance sword, so you can fight with things that are sort of intermediate to that, but no, normally are like more like side swords, so they don't bend as much. They still bend a bit, but they're mostly for cutting rather than.
But this is also where you met your husband,
Yeah. Yes. Yes.
who was in part, I think, from what I was reading, what allowed you to come to the U.S. or helped you to come to the U.S. But was that during the
No,
pandemic?
it was right before. It was in 2018. Actually, this is 7 years I've been in the US. I arrived in the US on the 27th of October of 2018.
Oh,
Yeah, this is, yeah, because I had just finished
happy
my
anniversary!
PhD. Yeah, thank you. I celebrate that. It was finished my PhD at the end of October, and I wanted to start my postdoc immediately after, so I came here so that I could start on the 1st of November. Yeah, I often think that moving across the ocean was a pretty big deal, and definitely was helped by knowing I had, some support.
A stabilizing
Yes,
force
for
helps you
sure.
to be able to
Yeah.
focus on what you need to do. So how did that change? Like, first of all, not just an entire. I mean, look, the U.S. is so dissimilar to a small town in Italy. And Ithaca is a unique place that is not forgiving in the winter, that's for sure. How did that shape your research and how you were looking at your future career? But coupled with that, once you entered the pandemic, how did that shape how you collaborated and taught?
Yeah, so I mean, I come from a small town in Italy, which means that I really like Ithaca because I like the small town vibe. Not during the winter, that's hard, that's harder, but in general, I really like the small town vibe. So when I came here, I was kind of like immediately like, okay, I think this is where I want to stay long term. Which, so I put a lot of effort into making sure that I could stay long term here. Let's put it this way. Um, but yes, I mean, a year in with my time at Cornell, the pandemic started, and first of all, I had never worked from home ever in my life. I was always kind of office kind of person. Um, and it was when the pandemic started, like, I don't know if I'm gonna be able to do this, as in, to sort of keep my discipline and keep working. Um, so that was tough. But on the other hand, yeah, it was also the way in which you could say, oh, but I can talk to all of these people. I can just email people and have a chat and talk to them remotely. So it did overall, it was a tough period, but it did help.
Um, all right. Well, I appreciate your time. I think this is eye opening for a number of people. I don't think I really fully understood geoengineering. I mean, to be honest, I still am only just scratching the surface. But to think that there's other systems beyond just our um, systemic use of energy and consumption, um, at least gives me some optimistic hope that there are other levers that can help accelerate some of this reversal.
I hope so too. Yeah.
So I I appreciate you illuminating this, and so I want to be sensitive to your time, but thank you again for coming on. Any closing thoughts or things you think we might have missed?
No, I think we covered a lot of ground. Yeah.
Well, really appreciate your time, Professor,
Thank you.
and
Thank you, my friend.
Keep doing your work.
Thank you. Appreciate it.
Thanks for listening. For a detailed list of episodes and show notes, visit scalesofsuccesspodcast.com. If you found this conversation engaging, consider signing up for our newsletter, where we go even deeper on a weekly basis, sharing exclusive insights and actionable strategies that can help you in your own journey. We'd also appreciate if you subscribed, rated, or shared today's episode. It helps us to attract more illuminating guests, adding to the list of enlightening conversations we've had with New York Times bestsellers, producers, founders, CEOs, congressmen, and other independent thinkers who are challenging the status quo. You can also follow us for updates, extra content, and more insights from our guests. We hope to have you back again next week for another episode of Scales of Success. Scales of Success is an Edge West Capital production.